All right, let's see. Once we get going. All right, looks like we're live. So, hello. The idea here is basically I want to do some TryHackMe rooms. I thought it'd be fun to do it with an audience, so of zero to many. Who knows. So basically, for anyone who's looking to learn a little bit of cybersecurity, anyone who's really at the beginner level, I'm just going to be going through a couple of the beginner rooms on TryHackMe. I think we'll probably do like one or two. I got a little bit of time, probably like 20-ish minutes. We'll see how long it takes, but I thought this would be a fun way for people to not only learn a new resource, right, learn about TryHackMe and kind of what it's doing, but also for anyone who's interested to learn about cybersecurity and get their feet a little bit wet. So the website we're using is called TryHackMe. I like this website a lot. I think it does a really good job of catering to beginners. Some of the other websites like Hack the Box and even Hack the Site and some of the other ones, it's a little bit of a learning curve. I know Hack the Box now has actually an academy set up, which makes it a little bit more manageable for beginners. But I really haven't seen too many websites do it as well as TryHackMe has done. So we're going to be using that. The room I thought we should start with is what is the name of it? It's just like Intro to Cybersecurity or something. Yeah, learning cybersecurity. We're going to start with this room, right? It's pretty fundamental. It's basically just going to go through a little bit about security when it comes to URLs, a little bit about security when it comes to some hacks that have happened previously, and then it'll talk about web request on like a very basic level without going into too much detail, but really just get people into the hacking mindset. One of the things I love about TryHackMe that they do really well is you have different rooms, and those rooms will allow you to have all the resources you need. For example, they just gave us a list of questions that we need to answer, right? And they can actually give hints if we need them. And when we hit View Site, it'll give us all of the resources needed for this lab. So a lot of times when it comes to other resources, you need to set up like your own personal lab, you need your own virtual machines and other shit like that. For this though, it's all encapsulated in the room itself, which I like. It's pretty cool. So this has been a fun thing to use for learning. But if we're looking at the first task here, right, just the TLDR of this text, as we're going through something called Bookface, and we're trying to hack into an account, right? And what we see here is when we hit next, it's showing us the profile. And for most people who just use the web regularly and are just kind of going around and going to social media and not doing too much or not like super aware in terms of like cybersecurity, all the different implications, there are always not always, but there are usually times a lot of vulnerabilities in websites and how they display information to you. For example, one of the things that I get frustrated as a user is if I'm trying to like log into a site and it says, oh, like incorrect credentials. It's like, oh, why don't you just tell me if it's like the username or password that's incorrect? And there's actually a security reason for that, right? If you're able to brute force and correctly guess somebody's, let's say, username, right, and then it says that the password's incorrect, that actually gives hackers information. So a lot of times websites, whether it's in their URL bar, whether it's in the way they respond to incorrect password attempts, they'll give away like a little bit too much information. And here, if we're looking, what we're supposed to see is actually what it's highlighting. Ben.spring is actually the username of Ben, right? It's the username of the user we're currently looking at. So I know a couple sites do this. I know LinkedIn does this a little bit. I don't know actually. Let me check if Facebook does that. Let's see. Yeah, Facebook does it too. They'll show your username up there, right? And it just gives away a little bit of information. So, how detrimental is this actually? It depends on how strong your password is, right? But here we're going to actually use this information later on in the room, right? So we got Ben here. Looks like a pretty cool dude. Plays tennis, football, likes to eat. Don't we all? And also has a pug. Funny story. A lot of people, I think it's like 30 to 40% of people use their pets as their passwords, right? So always good to keep that in mind if you're in the hacker mindset. All right, so the next thing it's saying is it's common for attackers to target the password reset functionality to look for issues that let them gain access to users' accounts. I know this actually happens a lot with Instagram. A lot of times hackers will abuse that functionality. I'm actually not super keen on how they do it specifically. I just have heard that it's been a pretty consistent issue. But so here we see all we need to do is enter a username, reset that password, and then we'll get to the next step. Right, so I'm just going to type in ben.spring. Right, once again, this is what we learned from the last slide up here. I see he has uppercase Ben, uppercase Spring, but I'm going to assume lowercase is fine. We're going to assume it's case insensitive. That's not always the case, but, you know. All right, and it says we have sent you an email with a 4-digit code. 4-digit code sounds pretty low. It sounds like a low amount of digits, something that would be brute forced relatively quickly. And that's actually what we're going to try to do, right? So basically what we've done so far, right? We've gone to guy's username, right? Ben.Spring's username, or Ben Spring's username, which is Ben.Spring. We've sent him a email reset, and now we're going to try to abuse that email reset because we see the amount of digits that are required is pretty low. Before we move to the next step, it's important to note with TryHackMe, there's actually on the left here a place to input our information, right? Input all the, we call them flags, all the flags that we find so we could track our progress. TryHackMe is really cool about how well it tracks your progress. You actually score points, and they put you in different like percentages and show you where you're strong and where you're weak, so it's pretty cool. But I'm just going to put in what we've learned so far, which is ben.spring is the username. I'm going to hit submit. We can also look at the hint just so you can see what it is, right? Look at the user's profile URL, right? We've just done that, so looks like we're pretty good to go on this at least. Next up, hack the Bookface account to reveal the task's answer. So that's going to be the next step, right? We've already set the reset code. We're going to hit this finger there, and it's going to say there are 10,000 different combinations of codes we can enter, right? Because it's a 4-digit number, right? That equates to 10K. We could try increasing them one by one, right? Going 0001, 0002, you know, and so on and so forth. But it will take forever. So try inputting any random reset code. Let's do, it's over 9,000 and hit submit. Okay. So what the website's showing us now, and this is where it's getting a little bit into web request. It's teaching us a little bit about the basics of web request. Is we just put in an incorrect reset code and we received a web request back, right, based on that code. How do I know that this web request is based on that code that I just input? Well, if you look here, we see reset code equals 9,000 and username equals ben.spring. Now, you don't need to understand the exact syntax of this, right? All you need to understand is that we input a code, that code went into a web request, and that web request returned a incorrect result, right? So now, if we're trying to go for the hacker mindset, right? Like what is a hacker thinking right now? Well, they're probably thinking, how do I put as many numbers, right? There's 10,000 combinations. How do I speed through as many numbers as I possibly can until I get a result other than incorrect? And I know we're talking about this from a pretty high level abstract perspective, right? But you know, this is just good to get the fundamentals down and to understand it. If we click here, it'll actually break down each piece of the web request, right? We see here, there's 4 pieces. The first is post, right? There's a couple options when it comes to web requests. We have get, put, post, delete, right? Post is when we're sending sending information, not location. When you're sending data or information to a website, right? You're usually using a post web request. And basically in this instance, they asked us for a reset code, and the information we sent back was the reset code 9,000, right? Next up, we have a user agent. This tells us about basically the browser that we're using, right? In this case, it's saying the web server. A lot of times, when it comes down to it, there are web browsers that have vulnerabilities, web browsers that haven't been patched. And sometimes getting the user agent of somebody's web browser, it's pretty good information, right? It's good and can let you know if they're susceptible to certain vulnerabilities depending on, did they update Chrome? Are they using Microsoft Explorer still, even though even Microsoft said that you probably shouldn't do that. After this, we have host. Host here is bookface.com. You might not hear it called this very frequently, but the host is usually the URL of the website, right? It's what's typically being referred to, right? In this case, it's bookface.com. You can see we cut out the beginning part, the HTTPS : // and we cut out the end of it. The host is just the meat and potatoes part of it, which is the host name, Bookface, and then .com, which is coming at the end. last but not least, this is what we talked about already a little bit. The reset code, we can already, even if we don't understand web request 100%, we can already see kind of how the syntax is being pieced together, right? We have the 9000, which is the code that we input here, right? The reset code. We have the username, right? Which we are currently trying to reset the password for. And they're separated with this ampersand, right? Which is showing that basically, think of it as like a line, right? It's separating, this is the reset code and this is the username, right? So we can kind of understand this web request a little bit, even if we don't have previous knowledge here. Yep, so this is the code. And now we're going to move on to the next section. So it's saying it's not going to be impossible, or it's not going to be possible to manually guess every code. Disagree. It is possible. It just sucks. Let's repeat the value, or let's repeat the code web request we sent earlier, and each time increase the code value. So what we're looking at right now, we have this same website that we're trying to guess the correct reset code for, and we now have this web request repeater. And what a repeater is going to do is it's going to send out a web request, and it's going to say, okay, is the code 0000? Okay, no, it's not. We got this incorrect text back. Is it 0001? Is it 0002? And it's going to do this for us automatically, right? Once again, a big part of cybersecurity, a big part of hacking, right? A lot of times when it comes to people attacking websites, a lot of it's automated, right? Nobody wants to be the guy to, manually guess every single possible password that it could be. So we use tools for that. And in this case, we have a tool down here called a website repeater, or web request repeater. So it's asking us to put in a code minimum and maximum value. I'm going to put the minimum as, I know it's a 4-digit code, 0000 is the minimum, and the maximum is going to be 9999. Now when we hit brute force, we're going to see, it went a little quick. Let's see if we could redo that. I can't skip that far. Interesting. All right, sweet. So we'll do it one more time. I want you all to look at the bottom here. Right, so this reset code, when we hit brute force, it's incrementing. It's doing it super fast, right? Faster than I ever could do it. And it found that the correct reset code, it went through actually 187 iterations. The correct reset code is 187, right? So this is our answer. Now you might be wondering, why can't I just type in here 0187 and hit enter, and it be correct, right? TryHackMe, it actually has certain questions that will look for flags, right? So we see this format right here. It says answer format and has 3 stars and then brackets and all that. This is signaling to us that it doesn't need the reset code. It actually needs some sort of flag that we're looking for here. Right, so what we're actually going to do, the last step is going to be still here. We're going to type in the correct reset code, 01887, hit reset password, and that'll bring us to our answer, which is THM, which stands for TryHackMe, and then in those brackets it says brute forcing. Let's make that a little bit bigger. There we got brute forcing. And that is actually our answer for the first section. All right, so if you were following along this far, you have now completed your first task within TryHackMe. Congratulations, you are now a hacker, honorary hacker. Task 2 is a little less technical, but it's still pretty interesting. To boot it up, right, once you finish task 1, you could collapse it. Then I'm going to open up task 2 here, and it's going to be a little bit more about networking, right? For those who do not know, if you're trying to get into cybersecurity or if you're just learning about cybersecurity, at the core of cybersecurity is an understanding of networking. It's really difficult, if not impossible, to jump directly into cybersecurity without any understanding of networking, right? So it's definitely good to build a basis there. So we got a little blurb about why networking is important, right? From scanning and identifying who and what is on the network to reviewing network logs, right? Networking is very, very big. I'm just going to click completed, right? Because it says to view the green site, right? Just to make sure we're doing that. And then we could boot the new site up with view site here. So this is talking to us about actually a real life event that happened in 2013. Target got hacked and it lost 110 million credit cards. And that's not 110 million, dollars worth of credit cards. That's 110 million credit card numbers, right? That's a crazy amount, right? There's only in the US, 300 something million people, right? Like 1 in 3 if we're assuming it's only US purchases. I mean, That's pretty crazy. That's a ton of people. So in 2013, Target was hacked with the attacker stealing credit cards from 110 million customers. It all started with an air conditioning unit. So when we click next, it's talking about the attack itself. Basically, the attack occurred on Target's air conditioning units. It can be controlled remotely, right? These air conditioning units were connected to the network. They were allowed to monitor the store's temperatures. And they were also connected, and this is the big issue, were connected to Target's main store network. Now this is true of Target, and this will also be true of your home and really anywhere you go as IoT devices or Internet of Things devices become more and more popular. The second you connect, smart lights or a smart fridge or the Alexa or all of these different devices to your network, you are increasing what is called an attack surface, right? The more devices you have on your network, the more likely it is that somebody can find a vulnerability on one of those devices. Let's say it's your fridge. They could root that fridge, and then they could try to escalate either vertically or horizontally, or basically just try to maneuver around your network, right? And there's actually a couple stories about people being hacked through their smart fridges. I think it was somebody, I want to say it was like 3 years ago, like 2018, 2019. Somebody's Gmail credentials were leaked via their smart fridge. And that's bad for a lot of reasons, right? If you lose your Google credentials, Google actually stores a lot of the passwords you use for other websites. So that's a big issue to begin with. And also, who wants someone reading your emails? That's bad too. That's not good. It's not just Target that can fall susceptible to the evil air conditioner, right? It's also us in our networks, right? So we got to be careful. We got to understand really just what we're doing to our security posture when we add these things to our networks here. So basically, as we were just talking about, an attacker compromised the smart air conditioning unit, which had a built-in computer, which is almost something that every device has now, right? From cars to phones to fridges now, right? And they were then able to access other machines within the store, such as the checkout tills, right? This is what we were talking about when it came to horizontal escalation. They didn't go straight to, Target's bank account, right? They didn't go straight to their Chase bank account. What they did first was they hacked the air conditioning units, and then they went to the checkout tills, right? Like maybe those self-checkout tills, maybe the ones the store employees used. And then once they compromised those, they were able to steal customer information, right? So pretty crazy. Now, if we hit next, it's going to give us more information. Once again, this isn't a technical task, but it gives us more information about the Target hack, right? These air conditioning units were not directly owned by Target. They're actually owned by another third-party company. This is actually a common case for a lot of companies, whether it's third-party software you're using, third-party devices, right? A big thing to understand is that every time you introduce some third-party whatever, it's increasing, once again, your attack surface, right? The ability for an attacker to find that third-party device, that third-party software, and to break into your network using it. So basically, they went through a third-party company to help monitor the store's temperature. That third-party company kind of screwed them a little bit. And if the network was properly segmented to keep Target's network and air conditioning units separate, the attack would not have been so severe. So what do they mean by that, right? Like, what does it mean to segment a network? The best way to think about it is this, right? Let's say you have different, I like to think of like strings connected to devices, right? Like just think of a line connected to a device. Most commonly what you'll see is in somebody's home network, they'll have their main network and then like a guest network. And the idea there is on your home network, right, your main network, you're having all of your sensitive devices, all of the things that you want to protect, right? And if you have a guest network, these two networks do not talk to each other. They're actually going to be separate, right? You don't want them to communicate. So in this situation, what they wanted to do, what would have prevented this attack from being so severe, was if they had all their air conditioning units, right, on one network that was separate from the checkout tills, right? But what they did instead was they meshed all of these together into one big network. So the checkout tills were able to talk to the air conditioning units and back and forth. And that's where problems arose, right? Because then when one of the dominoes goes down, then the rest of the store explodes. It like just goes up in flames. So this cost them $300 million. It's actually one of the questions here. How much data did it cost? So 300 million. Maybe I need a dollar sign. Nope, we're good. And then Target was even using a $1.6 million malware detection tool, which was also being used by the CEA and Pentagon. but attackers manage to fool the detection by pretending to be legitimate computer network traffic. So this last piece here, this is the reason why you cannot just depend on antivirus. This is the reason why you cannot just depend on having, tools, whether it's like a SIEM, which basically just like goes through your logs and like sets off alerts, or, like malware detection tools. You can't just trust that to be your only defense. You have to set up your networks in smart ways too. A lot of times what hackers do, right, is they know you probably have antivirus, right? Your target, you're a huge ass corporation. You definitely have some sort of defense, right? So what they're going to want to do is once they get into the air conditioners, they're going to try to make their traffic look as normal as possible and, make it seem like nothing's going wrong, right? Hackers, they aren't stupid. They were smart enough to hack into your AC, right? So they're also smart enough to know that they should hide their traffic and hide how malicious the activity that they're doing is, right? So, just because you throw money at a problem doesn't mean it's fixed, especially if your network segmentation's bad, right? Especially if you're just doing silly things. You're putting vulnerable resources in places where vulnerable resources should not be. It actually reminds me, I'm a big gamer. I like playing video games. It reminds me when you're like playing a video game and the final boss has like exploding crates near them, right? That you can like shoot and do damage to them. It's like, why would you put that there? Like, why? Like, what's the purpose? What does that serve? So this is like the exploding crate of Target, right? It was, why would you put in this air conditioning unit next to all your like valuable shit if it could easily be hacked, right? Shouldn't do that. In the same way, the boss battle, maybe put the exploding crates in the storage unit. Don't leave it near the boss battle guy. All right, and then last but not least, learning networking is important. I agree with this. Knowing how computers talk to each other over a network and how data travels from 2 points will allow you to understand what happens when you start the scanning process, scanning a network, finding machines, finding weaknesses in applications and systems. Yeah, snaps to that, right? Like, absolutely true. On TryHackMe, learning is fun and realistic. Cool little advert there, right? So we got this done, and now we are on our last task, which is really just a roadmap, right? So learning roadmap, we just did pre-security, and it's recommending us to go into 2 different ones. To my knowledge, I think these are 2 intermediate paths, so I'd actually probably suggest you guys start with like learning Linux fundamentals if you're really, really new to the space. But yeah, here we see 2 of the recommended rooms to go to next. No answer needed, right? Hit complete, and you will now have completed your first room, right? And they give you a little confetti there. All right, cool. So we just completed our first room. Let's see. Let's do one more. I think I got time for one more. Let's do. I think the Linux one will be cool. I like Linux. All right, so we got Linux fundamentals. I'm actually gonna, let's reset progress so it looks new for all of us. Nice. Okay. This is just the starting blurb, right? You're most likely using a Windows or Mac machine. Both are different. Gonna hit complete. I'm not an avid intro reader. Okay, where is Linux used? It's fair to say that's a lot more intimidating to approach than operating systems. When they say more intimidating than operating systems, they mean like Windows, right, or like Mac OS, right? Whatever you're used to when you turn on your Mac device or your Windows device, right? That's like an operating system. A Linux terminal, on the other hand, is, and I'll show us in a second. Let me start it up. A Linux terminal, on the other hand, it does look a little bit scarier. It looks like the kind of shit you'd see in movies, right? So for anyone who's not super technical, that's, like that's going to be pretty intimidating. So this, we're actually booting up the machine right now. It's another thing I like about TryHackMe. I was talking about it before a little bit. Everything is contained into like this one cool room. You don't need to set up your own lab. I don't need to spin up a virtual machine, which is like a mini computer, on my own hardware. But while that's spinning up, we're just going to look at the background a little bit more. So we have Linux. It's more intimidating than operating systems. I agree with that. Both variants have their advantages and disadvantages. For example, Linux is considerably more lightweight, and you'd be surprised to know there's a good chance you've used Linux in some form or another every day. Linux powers things such as websites, car entertainment, point of sale, critical infrastructures, right? All interesting stuff. My experience with Linux, in one of the big advantages of it, is it's really easy just to automate tasks, right? So with Linux, once you get really good at like learning the Linux command line and doing a little bit of what's called like shell scripting, you'll be able to just like automate a lot of boring tasks that take forever. It's also a lot quicker, honestly, in my experience, to use the terminal when you're good at it than to like double click everything, right? You know, think of how you usually use a Windows machine. Typically, you see like some sort of dashboard and there's like icons and you double click those. It's actually usually pretty fast to honestly just use the Linux terminal to do a lot of that. All right, next up, flavors of Linux, right? Linux is actually an umbrella term. Basically, there's all of these different systems. One form, I'll actually try to pop it up. One form of Linux I use a lot in cybersecurity is Kali Linux. It's basically considered, it's weird to call it a hacking OS, but it's used by a lot of pen testers. So let me show you. Let me sign into it real quick off stream. All right, so this is what I am used to. Let me clear out what I was working on. So I use this operating system a lot, right? This is a form of Linux. It's called Kali Linux. The reason I like it and the reason a lot of like pen testers use it is it comes preloaded with a lot of tools, right? We got information gathering tools, OSINT tools. We got some web sniffers, or excuse me, network sniffers like Wireshark, password attacking tools, right? It basically just comes preloaded with a lot of stuff that I would have had to manually configure on my own. So Kali Linux is an example of what they're talking about, which is a flavor of Linux, right? It's pretty cool, right? So basically, one of the cool things about Linux, which is different than Windows, Windows 10 is Windows 10 for you, it's Windows 10 for me, and it's Windows 10 for everybody else, right? But Linux, right, there's all these different flavors. You know, you have like Red Hat Linux and Kali Linux, and you have SIFT VMs for digital forensics, and all of them come preloaded with all these different tools and all of these, basically these different things that we can use, and it's pretty cool, right? Then it asks, in what year was Linux first created? I actually don't know. Does it say that here? That might be a Google search. All right, so they got us Google searching a little bit. What year was Linux released? All right, 1991, I guess. Yeah, I do not remember this room. Okay, cool. Yeah, they had us do a little Googling on the side there. All right, I think the next one's actually technical. Yep, should be. So this task, right, if you all are on task 3, it's basically just showing us how to start up the machine. If you didn't see it before, basically I just click start machine, and it created this like split window where on the left we still have all of our stuff in TryHackMe. On the right we have the actual machine that we're using. So pretty cool stuff. Let me pop up this. All right. So for this, the only thing to really complete here is just saying I've deployed my first machine. It's going to trust you, right? So don't lie to it and, you know, steal points. All right, and now it looks like we're doing some of our first commands. So it's having us do the command echo and the command who am I. Echo is going to output text that we provide, right? What does that mean? If I type in the command echo, I'm on the terminal on my right now. So if I type in echo, and then if I put in quotations, let's do the classic hello world. All that's going to happen when I hit enter is it's going to spit that output into my terminal, right? It's going to print it right here. So when I hit enter, we can see hello world has been printed out, right? When is this benefit? Like, why would you use a tool like this? Doesn't it seem kind of useful to just, or useless to just print shit out, right? Well, you could actually write scripts where you're putting prompts in, right? So, or most commonly, I use it to prompt a user. I'll say like echo and then input number 1 through 5, right? And basically, when a user runs my script, they're going to see input a number 1 through 5, and it'll basically tell them what to do, right, to make my script work, right? So echo is actually a useful command. In the beginning, you're going to see almost zero use for it, right? It's going to seem silly that you're just printing out something you just typed. But for now, it's good to learn just to have in your back pocket here a little bit. Next up, we have who am I? Not only is this an existential question, it is also a technical one. So who am I is basically just figuring out what user we're currently logged in as. Why does this matter for cybersecurity? When you're hacking, right? If you're breaking into networks, right? If you're pen testing, ethically, of course, and you're trying to figure out what user you are, by typing in who am I, I'm going to go to my terminal on the right, who am I, it'll tell you what user you're currently signed in as. So if I'm trying to break into a network, best case scenario, when I type in who am I, it says I'm admin or root and my job's done, right? I basically have owned the system. More likely than not, I'm probably going to be a random user. I'm going to be some low-level user. I'm going to have to work my way up the chain to get to that root user, right? So now it's saying if we wanted to output the text, try hack me, what would our command be? And now I'm going to clear out my screen just to make it clean. The way to do this, let's also make, I can't make the terminal bigger. Oh, actually I can. I think I can. Let's check. Oh, down here maybe? Nope. That's extension. All right, well, I can't make the terminal text bigger. I can only make the text on left bigger. I apologize. But what it's saying now is if we wanted to output the text, try hack me, what would our command be? So we know since we're outputting text, the command I'm going to use is echo. I like to think of it, just to remember it, as like you're yelling into a cave, right? Think of a cave with an echo. I go, hello, and then the cave yells back, hello, you know? It's basically the same thing. I'm typing out hello, and then it's going to spit that back at me. For this problem, it wants me to do try hack me instead of hello, right? So I'm going to do a space, quotations, try hack me, end quotations, and I'm going to hit enter. And if we did this correct, which we did, it'll print right here, right? We can see try hack me has been printed. So this command right here is actually our answer to that first problem. Right, so let's see. When I highlight it, does it paste it? No, it doesn't. So what we're going to type in now is we're going to type in, you can actually see the format at once. We're going to do echo, space, quotations, try, hack, me, and quotations, and hit enter. It says incorrect. Let's take actually the quotations away. All right, it did not like our quotations, unfortunately. So you could do it either way, quotations or not. If you take away the quotations, right, and hit enter, it'll still work. Usually when you have spaces in it, right, people use quotations just to be clear that it's still part of one string altogether. But for the purposes of the answer, they wanted it without quotations. Next up, what is the username of who you're logged in as on your deployed Linux machine? Right, we just talked about the existential question, right? Who am I? All I have to do for this one, I don't have to type anything else in. I just have to type in the command, who am I, and hit enter. Ooh. Well, actually, the second thing you have to do is you have to spell it correctly. So you have to type in who am I, hit enter, and we could see I am TryHackMe, right? And that is our answer to this task number 4. Well, that's pretty cool. If you're wondering how I'm clearing my screen so easily, I'm actually hitting Control L. That'll clear my screen out. Another way to clear this screen, I'm going to add some crap to it, is you could type in the word clear. This is another Linux command and hit enter, and that'll reset your screen so that you're all the way back at the top, right? All right, next up, task 5. So far we've covered echo and who am I, right? Pretty cool. Not all that useful when you consider things that we need to do. I would argue it becomes useful later on when you start doing more scripting, but yeah, I agree. Not super useful right now. Now what we're going to do, and this is where we get into like the real meat and potatoes of Linux, right? This is the kind of stuff that starts mattering right now, right? We're going to learn about ls, which stands for listing, cd, which stands for change directory, cat, which stands for concatenate, pwd, which is print working directory, right? And all of these are going to be used to interact with our file system. So to start us off, right, we have ls. I type that into my terminal on the left. This stands for listing. And when I hit enter, it's going to list all of the different files in my current directory. What does that mean, right? As somebody who does not use Linux, as somebody who does not use the file system using a terminal, right? What does that even mean, right? Well, if we open up this, I'm going to show a file system we're probably more familiar with. Let's open a folder here. So the best way to think of ls, let's go to desktop, right? Documents, maybe. Pictures. Yeah, we'll do it this way. So the best way to think of ls is this, right? When we're using the file systems, what I'm currently doing is to go into a folder. I'm going to double click on it, right? I just double clicked into that Kali folder, and now I see all of these contents. The way to see these contents in a terminal is to type in ls, right? So what I currently see in what we call a graphic user interface, this is what you're used to using, what I currently see is the same output I would get if I used ls here, right? I'll show that actually side by side. So let's make this window not ugly if I can. All right, oop, we had it and then we lost it. Take two, take three, take two. All right. All right, so here's the side by side, right? Really just to nail in this point. Okay, on the left, this is the way you're used to using file systems, right? This is the non-techie way, right? This is the way everyone knows. You just double click on a folder and it brings you into another folder and you see what's in it. When I type ls in Kali, right, in my terminal, you're going to notice something. You're going to notice that all of these different names match what we see here. By typing ls, I basically have just provided myself the same information that the graphical user interface that we are used to using will provide me, right? So this is the terminal way of seeing what's in my folders. And then once again, the non-terminal way is by just using your eyes, right? This is the graphic user interface way. So when we type in ls, stands for listing, right? And that's basically all we're doing there, right? Once again, this is the way people are used to doing it, right? The non-technical way when you use this, the graphic user interface and you're just double clicking your way through all your file system. But when we use the Linux terminal, we use ls to actually list those things, right? So pretty cool, right? We've just used the terminal to do the first, we'll call it useful thing, right? You know, I know it's not groundbreaking yet, but we'll keep going forward, right? So this is ls right here. Next up, right, we're going to learn cd, right? So we got cd, it stands for change directory. This is actually a pretty good name, right? cd for change directory. It's relatively self-explanatory. Just to show it in my Kali machine real quick, let me clear it out. And let's go up a folder on both sides. Okay. So, all right, basically, let's do ls here. All right, we see on the right and the left, we see the exact same thing, just in two different ways. On the left, this is the way we're used to navigating our file system. On the right, this is the cool new way, right, that we're learning. So on this left, we see Kali, it's a folder, and to go into this folder, all I have to do is double click. Now on the right, since we don't use the terminal, since this is our first time using it, you're probably like, I can't double click on the text. Like, how do I jump into this? Well, this is where the next command we're learning comes into play, the cd command. So I'm going to type in cd and then the word Kali and hit enter. And that's going to bring us into this folder, right? So we've basically just navigated into this file system, right? Basically just navigated into this folder. But now what you're probably saying is, oh my gosh, I can't see anything in this folder though. I still, it's kind of useless, right? Well, this is where the first command we learned comes into play. We type in ls and hit enter, and we're now able to list all of the information once again, right? So now with two commands, we've just done this, right? This is how you used to do it, right? You used to double click and then use your eyes to look. But with two commands in the terminal, we've just done that same exact thing, but in the cool hacky way, right? All right, so we just covered this. We just covered that. Now what we're going to learn is how to use the cat command. The best way to think of cat is you're basically just going to read a text file. Think of like Notepad or whatever, right? Whatever text editor that you use, Google Docs. We're going to read it through our terminal, right? So in the example that they use, they do cat and then the name of the file we're going to read. Let's try it on access.log. Let's see if we can actually read that. I'm going to type cat and then access.log and hit enter. And we are now reading this file, right? Think of this like, once again, cat is basically as if you opened it up in Microsoft Word or something like that, whatever tools you're used to using. It's uglier. I will say cat is uglier. It's just printing directly to your terminal. So that is the downside of it. To clear this out, I'm going to do Control L, right? You all can do the same. And I'm going to type in ls again just to see, once again, what is in our folder that we're currently in. So the cat command, once again, is used to read a file, print it to this screen here. And the access.log is a pretty huge file, so it just prints out a ton of shit. And then the last command we learn, pwd, right? We're going to type in pwd, hit enter. This is going to give us our working directory. Working directory, this is something that you will understand later on. You've probably seen it before, right? Like you've seen it with like Windows systems where it's like your C drive, it's like C, users, whatever your username is, documents, right? That's like the path to get to a file. The best way to think of file systems, think of it like a tree, right? There's like the main branch and then all these different branches going down, right? So the main branch is like your C drive, and then you go to the users, and then you go to the specific user, and then like the downloads folder, right? That's basically just how it works. In this case, we're seeing the path that it takes to get to the folder we're currently in. So first question, right, to answer these together, how many folders are there? Right, in order to answer this question, assuming you were starting from nothing, all you have to do is type in ls and hit enter, right? And now we're going to count 1, 2, 3, 4. Answer 4. Which directory contains a file? Okay, now this is going to be a little bit trickier. We're going to have to go into the directories and check out which one has a file. Let's use the commands we learned for this. There's more complicated ways of doing this, or more complex, but let's do it the way that we've currently learned. That just makes the most sense. So what I'm going to do is let's go into our first folder, right? I'm going to use the cd command. I'm going to do cd folder 1. I can tell I'm in folder 1 because it has this little additive to my line. You could also double check by doing pwd, which is print working directory. And if you see folder 1 here, you have successfully navigated to folder 1. Now to check the contents of folder 1, I'm going to type in ls. Seems like there's nothing, right? Okay, so it's not folder 1. That is crossed out. In order to go backwards a directory, what we can do is we can use the cd command, right? Once again, whenever you're moving directories, you're always going to use cd. But to move backwards, this is going to be a little bit weird. We can use 2 periods. And this will actually back us out 1. So when I hit enter, you can see folder 1 is gone. When I type in pwd to see where I am, we're in the home TryHackMe directory. We're no longer in the home TryHackMe folder 1 directory. By doing this command, we have now moved to the left 1 directory. I'm going to do Control L, clear out again. ls. Let's try folder 2. Let's see what's in folder 2, and it's nothing. Once again, I'm going to move backwards to the left 1 directory. ls once again. All right, we're in the right spot. Now I'm going to go into folder 3. Right? We're going to repeat this for the last 2 folders. ls, nothing's in it. cd folder 4. ls. And here we see note.txt, right? So our answer, which folder contains a file, or which directory contains a file, it's folder 4. What is the contents of this file? All right, the contents are, well, we see the name of it. We don't see the contents though, right? So now we have to ask ourselves, how do we read the note.txt file? As we were saying before, if we look at all the commands we have, I want you all to guess, right, which one you'd have to use. You have 4 options, and guessing time's over. Cat is the correct answer. So if we type in cat note.txt and hit enter, the contents are hello world, which is our answer for this part. Hello world, exclamation point. Hit submit. Awesome. Next up, use the cd command to navigate to this file and find out the new current working directory. What is the path? So we're already navigated to that file, right, which is great. I'm just going to type in pwd. Let's get that working directory. So we see /home /TryHackMe /folder 4. We could actually just copy this. This is exactly the answer. So let's do home TryHackMe folder 4. All right. Okay, so I'm running, it looks like we're at about 43 minutes. So I'm going to cut the stream here. Let me know if you all enjoyed it. We'll finish the rest of this room on the next stream, whenever that is. But I'll be keeping this on Twitch. I'll probably post this on YouTube too. You know, I like double posting. It's always good just to, you know, spread to as many different mediums as I can. But yeah, let me know. Let me know what you all thought. Did you like learning Linux and cybersecurity via, you know, walking through a TryHackMe room with me? What did you like? What did you dislike? Always love that feedback. And for those who watched and tuned in, and for those who will watch and tune in, thank you all for watching, and I appreciate the support. Thank you.